Today we're going to talk about rationalizing fractions. But before we get to rationalizing fractions, we need to digress for a couple minutes and go back and refresh our memory on how do we simplify a radical. So what we're going to do when we're simplifying radicals is we are looking for two of the same value to take out one. So if we start with the square root of 63, find two factors of 63. The first ones that come to my mind are 9 times 7. And then rewrite these. 9 is 3 times 3. We can't do anything to 7. And what we're looking for is we're looking for two of the same value to take out 1. 2 3s. We're going to take out 1 3. And when we simplify, we get 3 times the square root of 7. And that's the same basic process for all of these. Although when we look at this second one on letter B, do we know what the square root of 36 is? And you probably do. It's 6. And because we can take the square root, we're not going to write a radical anymore, not a square root symbol. 36 is 6, and notice that I just wrote it as 4 times 6. And 4 times 6 is 24. So we're not always going to have a square root symbol in our answer. And after we looked at a couple of those, then we threw in a negative underneath the square root. And what's the square root of -1? I. And the more you say it out loud, the more you're going to remember it. And it sounds like a lot of us remembered it, which is awesome. And now we want to find factors of 18. Somebody said 9 and 2. If you pick 6 and 3, that's fine. And all of a sudden I started speeding up here. I need to slow back down. But again, square root of -1 is I. We're going to make our factor tree with 18. We're looking for two of the same value to take out 1. And we end up then with 3I times the square root of 2. Finally, over here on letter D, when we get a fraction, what I can recommend is to rewrite the fraction as the square root of 4 divided by the square root of 5. You can separate the fraction into two separate square roots. Can we take the square root of 4? It's 2. Can we take the square root of 5? No. And when we were learning to simplify radicals earlier in the year, we left the answer in that form. But in general, mathematicians don't like leaving a radical symbol in the denominator, which I think is about what my next screen says here. Let's think about the last example for a minute. In the past, especially geometry class, you were told that mathematicians have this convention that we don't like radicals in the denominator. And that's the bottom of the fraction. And because of that, mathematicians came up with a way to not have a radical in the denominator. And if you look at the title of your notes, what that's called, if we want to get the radical out of the denominator, it's called rationalizing. Process called rationalize the denominator. So here's how rationalizing the denominator works. So originally it says multiply the original fraction by a fancy form of 1. Well, the first thing we did in this problem is we rewrote this as the square root of 4 divided by the square root of 5. And then what we did is we took the square root of 4 and we said that's 2 divided by the square root of 5. what we're going to do, we want to get rid of the radical in the denominator, so we're going to multiply by a fancy form of 1, which says the denominator has a square root of 5. So we're going to multiply the denominator by the square root of 5. But if we multiply the bottom of the fraction by the square root of 5, we have to multiply the top by the square root of 5 as well. And the square root of 5 divided by the square root of 5 is the fancy form of 1. So it says, in this case, multiply the fraction by the square root of 5 over 5. And when we do this, we end up with, and I'm going to write the answer down here under number 2, we end up with 2 times the square root of 5. Notice that we could multiply these together. The 2 stayed a whole number, the square root of 5 stayed that. And down here in the bottom, square root of 5 times square root of 5 is square root of 25. And it says, simplify the numerator. Well, that's done. We can't do anything else to it. Can we simplify the denominator? We can. So 2 square root of 5 stays as is. Square root of 25 is 5. And it turns out in this case here, that is our solution. That's our simplified version here. Finally, it says simplify the fraction fully. Well, we cannot do anything else to this problem. So there it is simplified fully. Notice that there is no radical in the denominator. So that's our step. Fancy form of 1 is going to be the really important idea behind this. As we look now at some more specific examples, once again, what I can recommend, rewrite the fraction as the square root of 4 divided by the square root of 3. Can we simplify anything in this? We can simplify the 4. The square root of 4 is 2. I'm going to write it underneath there because I need some space. So this is 2 divided by the square root of 3. Well, our goal today, the theme of the entire notes is that we want to get rid of the radical in the denominator. And in order for us to do that, we're going to multiply by the square root of 3 on the bottom. And the reason that I picked the square root of 3 this time is because that was what was already there. And if we multiply the bottom of the fraction by the square root of 3, we have to multiply the top by the square root of 3 also. Fancy form of 1 is the square root of 3 divided by the square root of 3. So when we multiply those two together, we end up with 2 square root of 3. Again, notice that the 2 stayed out of a square root. The square root of 3 stayed in. And our bottom of our fraction, square root of 3 times square root of 3 is square root of 9. Can we take any square roots now? And square root of 9 is 3. So we end up here with 2 times the square root of 3. Let's try another one. With respect to the fractions. Again, break it apart. What we do, we get the square root of 3 divided by the square root of 4. Can we take the square root of either one of those values? We can't take the square root of 3, but we just saw it earlier. We can take the square root of 4, which is 2. Now that we've simplified that fraction, we don't have a radical in the denominator, so we have simplified this fraction completely. Square root of 3 over 2. But as we look at examples C and D here, there's nothing that we can simplify to start off with on either one. Maybe a little bit on D, but not much. So what we start off with here is we want to get rid of the radical in the denominator. We're going to multiply by the square root of 2. Once again, the reason that we picked the square root of 2 is because it is the value in the denominator, in the bottom of the fraction. If we multiply the bottom by that, we're going to multiply the top by that as well. Fancy form of 1. Well, 1 times the square root of 2 is square root of 2. Square root of 2 times square root of 2 is square root of 4. Can we simplify either one of those radicals? And we've seen the square root of 4 in almost every example, so yes, we end up with the square root of 2 over 2. Letter D. Technically, we can take the square root of 1, but our main goal, once again, is to get rid of the radical in the denominator. So let's multiply the denominator by the square root of 3, because that's what's in the denominator already. And if we multiply by the square root of 3 in the bottom of the fraction, we need to multiply by the square root of 3 in the top of the fraction. And then we multiply. 1 times 3 is 3. And 3 times 3 is 9. Still both underneath the radical. But once we multiply those, can we simplify either one? And we see that we've got the square root of 9, something different at least this time. And we come up with the square root of 3. Can't do anything to that one. The square root of 9 is 3. Let's flip our paper over. Once again, the whole goal here today is to get rid of the radical in the denominator. On letter E, we've got the square root of 6. So let's multiply. And by the way, the square root of 6 in the denominator, let me be a little bit more clear. If we multiply by the square root of 6 in the denominator, we need to multiply by the square root of 6 in the numerator. And we end up with then 4 times the square root of 6 divided by 6 times 6 is 36. And we're following the same process that we've been following on all of them. We know that this process is going to help us eliminate the square root in the denominator, and it does. This gives us 4 times the square root of 6 divided by 6. Square root of 36 is 6. What we really haven't dealt with is that part C, which says, finally simplify the denominator fully. Well, we can simplify this part of the fraction. And if you're not good with fractions, then pull out your calculator and just type in 4, 6. And we get 2/3. So when we simplify this completely, we end up with 2 square root of 6 over 3. Letter F. Getting rid of the radical in the denominator. We want to multiply the bottom of the fraction by the square root of 8 and the top of the fraction by the square root of 8. When we do, we end up with the square root of 8 divided by the square root of 64. 8 times 8 is 64. Notice they're both still in the radical. But as our goal is to get rid of the radical in the denominator, then what this becomes is it becomes the square root of 8 over 8. But watch out in this kind of problem, because even though we got rid of the radical in the denominator, we've got the square root of 8 in the numerator, and we can simplify the square root of 8. 8 is 4 times 2, which is 2 times 2. So it's 2 times 2 times 2 And what we're looking for are two of the same value to take out 1. So our numerator then becomes 2 times the square root of 2, all divided by 8. And lastly then, see if we can simplify anything. And in this particular case, again, it's going to be the parts that aren't underneath the radical. 2/8. If you're not good with fractions, you can go to your calculator and do 2/8 and get 1/4. If you want to write 1 radical 2 over 4, I'm fine with that. If you don't write the 1 in front of the square root of 2, I'm fine with that. In fact, let me put 4 here. And as we finish, once again, we want to get rid of the radical in the denominator. When we take a look at this, we've got the square root of 16 divided by the square root of 7. I don't know why I just wrote that problem down again. It was right there. The only thing that I did do is I split apart the fraction. Can we take the square root of 16? Yes, but we can't take the square root of 7. So this is 4 divided by the square root of 7. And now what we want to do is we want to get rid of the radical in the denominator. So we're going to multiply by the square root of 7 here. We're going to multiply by the square root of 7 here. When we do that, we get 4 times the square root of 7 divided by the square root of 49. Again, for a couple of you, you might not need to show that step because we've got the square root of 7 times the square root of 7. There's the two of the same. Take out 1. But as we finish them, we get 4 times the square root of 7, and the square root of 49 is 7. There's nothing else that we can simplify in this particular problem. Nothing cancels out with the 4 and the 7. So lastly, we've got the square root of 5 divided by the square root of 3. So it's already written in fraction form for us, split up fraction form. And what we want to do is we want to get rid of the radical in the denominator. So we're going to multiply by the square root of 3 here. Then we're going to multiply by the square root of 3 there. Fancy form of 1. When we multiply the tops of the fraction, we get the square root of 15. When we multiply the bottoms of the fractions, square root of 3 times square root of 3 is square root of 9. Can we take the square root of 15? No. Can we take the square root of 9? Yes. And there we've gotten rid of the radical in the denominator. You cannot divide the 3 into the square root of 15 because the square root of 15 has a square root symbol and the 3 does not. So as we finish today, we work on the practice problems here at the end.